Hello, we are from Group 1 and we are presenting Experiment 7, Torricelli's Theorem. For the report summary, Experiment 7 is an experiment to verify Torricelli's relationship by comparing measured and theoretical values of velocity and to find the relationship between Bernoulli equation and Torricelli law. Torricelli's law is a theorem that relates the exit velocity of a fluid from a hole of a container. The exit velocity of a fluid depends on the height from the floor to orifice. As water level rises, water passage decreases, thus decreasing water speed. Next is for the theory part.
For the theory part, Torricelli law, also known as Torricelli theorem. Torricelli theorem is a theorem in fluid dynamics relating the speed of fluid flowing from an orifice to the height of fluid above the opening. The law states that the speed v of efflux of a fluid through a sharp-edged hole at the bottom of a tank filled to a depth h is the same as the speed that a body, in this case a drop of water, would acquire in falling freely from a height. Example, v equal to square root 2gh, where g is the acceleration due to gravity, 9.81 meter per second square near the surface of the Earth. This expression comes from equating the kinetic energy gain 1 over 2, 1 over 2 mv squared with the potential energy loss mgh and solving for v. Next. The exit velocity from a hole in a column of fluid is given by v equal to square root 2gh, where h is the difference in height of the top of the fluid to the hole, h equal to h2 minus h1. To measure the velocity, we measure the range that the fluid travels before it hits the ground after it has dropped a distance. From projectile motion, this relationship is Vt equal to x 1 over 2 gt squared equal to h. By eliminating the time, we obtain the simple result, which is v squared equal to 1 over 2 gs squared over h. Next, I'll pass to the next presenter to continue the procedure.
Hi, I'm C. I will continue for the procedures. First, the apparatus was set up based on different heights of stages. The measurement of height is between the floor and the desired orifice. The cylinder tank was placed at H1. Next, the cylinder tank was filled up with water. And next, the hole at the cylindrical tank was covered to stop the flow of water at the desired volume. Then our finger was taken out from the hole, and at the same time the maximum distance was marked using the crack and the time was recorded. Next, the experiment was repeated by using different volume of water and at the different heights of stages H2 and H3. After finished, all the apparatus were removed and reading was recorded in table. Next, I pass to the next presenter.
I will carry on for the data analysis part. As usual, we have a few things we need to record and a few things we need to calculate. This time, we have volume of water in liter, initial water level H in meter, R1, R2, R3, and average maximum water trajectory distance X in meter, also R1, R2, R3, and average time taken for water to drain out T in seconds, R1, R2, R3, and average. Then water flow rate Q in meter cube per second and velocity of water V in meter per second. Here's our findings. This is the result obtained for height from floor to orifice is 36.65 centimeter. This is table 2. The result obtained for height from floor to orifice is 56.45 centimeter. And this is table 3. The result obtained for height from floor to orifice is 76.15 centimeter. Now I pass on for the discussion part.
For the discussion part, the first part will be explain about the selection on dependence, independence, and constant variables. The dependence variables is the flow rate of water out of the bottle, measured in meters cubed per second. E is the effect of independence variable, which means its value depends on changes in the independent variable. The independent variable is the cylinder tank that filled with water. It is the cost and its value is independent of other variables in the study. The constant variable in this experiment is the density of the water. The choice of this variable is to fulfill the Bernoulli principle assuming that the fluid is incompressible, which is v squared over 2 plus gh p over 5 equal to constant. Next, I'll pass to the next presenter to continue the second part of the discussion.
Hi, my name is Ainada, and I will continue to the second part of the discussion. So, in this second part of the discussion, we need to clarify on how we can relate the Bernoulli equation with Torricelli law, and we need to show all the derivation and explain each step. So, by using the Bernoulli equation, we actually can use derivation to obtain the Torricelli law, which relates to the velocity of fluid leaving an orifice in a fluid-filled container to the head of the fluid above the orifice. So this is the Bernoulli equation, which is P1 divided by rho g plus V1 squared divided by 2g plus Z1 equals to P2 divided by rho g plus V1 P1 and P2 is at the atmospheric pressure, thus both of them are zero. The initial velocity V1 is so small that it almost reaches zero, therefore it is also considered as zero. Z2 is also considered as zero as it is set at datum. Thus the equation will be going to be Z1 equals to V2 squared divided by 2g. Then after we rearrange the equation, we will get the Torricelli law, which is V2 equals to square root of 2gz1. Next. So the third part of the discussion, we need to calculate the percentage of relative error for the theoretical and measured experimental values. So the percentage of relative error can be calculated by using the data analysis, which is V theoretical and measured velocity. And for the 36.65 centimeter, the average percentage error uh, obtained is 29.26%. And next, and then the second one, 56.45 centimeter, the average percentage error obtained is 26.66%. And then the last one, we have the 76.15 centimeter, and its percentage error is 45.66%. Next, we move on to the last part of the discussion part, which is we need to list out the source of error and method to minimize error. So the first source of error is parallax error, and the method to minimize the error is the observer need to ensure their eye level are parallel to the reading scale, and the second one is hole is not covered properly. So a method to minimize this error is a stopper or strong tape can be used to ensure to have no leakage will occur. And then the third one, inaccurate time taken, or we can also say human reaction error. And a method to minimize this error is time need to be taken several times and calculated the average. So that's all for the discussion part. I will pass to the next presenter.
Next, I will continue the conclusion of experiment. By comparing measured and theoretical velocity values, we were able to confirm Torricelli's relationship. The water height is changed in this experiment to determine the measured velocity and compare it to the theoretical value. We aim to measure the water velocity as the height of water change. We found that the velocity of water is directly proportional to the height of the water. The percentage error for each height is 29.26% for H1, for 26.66% for H2, and 45.66% for H3. Some recommendations to minimize error in this experiment is to make sure to conduct the experiment in an ideal condition while there is less disturbance. We must make sure that all apparatus is functioning well to avoid error. That's all for our group. Thank you.